Hi, this is Harold again with JMP, and I want to talk about regression today using JMP. And I want to use a data set called Hollywood Movies, which first show you how to find it. Clicking on the Help button, Sample Data. Since I'm looking for regression, I'm clicking over here on regression, and Hollywood Movies is right here. Our variables are here on the left. We have 14 variables, 136 observations, 136 movies. And we have variables like the movie, the name of the movie, which studio produced it, Rotten Tomatoes score, an audience score, the theme, genre, the number of theaters on opening weekend, box office, box office income per theater, domestic gross in millions, foreign gross, world gross in millions of dollars, our production budget in millions. The profitability is a ratio of the world gross divided by the production budget. And we have finally the opening weekend gross. I'm not going to use all of these variables, but I've selected some to look at. Let's start by clicking on Analyze and just do a distribution, a way of doing a little bit of data auditing. Here's the Rotten Tomato score. Holding the Control key down, I'm going to click on the number of theaters on opening weekend, the production budget, and the opening weekend gross. Those four variables, remember I have my Control key down, and clicking on OK, I get the picture of all the different distributions. One thing to notice, we've got some outliers, and hovering over a data point, we can see opening weekend gross is pretty high for Harry Potter and the Deathly Hallows Part 2, and looking at the other variables, other movies. Without doing too much exploratory analysis, I'm going to try to predict the world opening weekend world gross based on these four variables here. So let's do Analyze, fit y by x. I'm only going to be doing simple regression here. And here's the world gross as my y variable. And I'm going to use the Rotten Tomatoes score, the number of theaters on the opening weekend, production budget, and the opening weekend gross as my potential x variables. I'll be doing 4 simple regressions here, and you'll notice that because all the variables are with this blue triangle, meaning they are continuous variables, both my y variable and the x variable are continuous. I'm going to get a scatter plot for which I can do a regression. I click on OK, and there are my 4 plots. Y variable is the same in each of the 4 plots. I have a different x variable in each of the 4 plots. I want to do a regression, 4 simple regressions, regressing world gross on each of the 4 independent variables individually. So just simple regression. Holding the Control key down allows me to apply the same operation to all 4 of the graphs around there. I get the estimated regression equation in each of the 4 cases, and I can look around and see how the goodness of fit, just eyeballing it. The variable number of theaters opening on weekend doesn't look very linear, and so that might pose a problem. This variable for the production budget looks like the variation about the regression line is not constant. It's not uniform. The spread becomes larger about the line as we have larger production budgets. Some of that happens here, but not so much on the opening weekend gross. So let's concentrate on opening weekend gross as a independent variable trying to predict the world gross. You notice the R square is 81.6%, meaning about 81% of the variation in the y direction has been explained by this regression. First thing I look at is the sign of this slope coefficient. The estimated slope coefficient is a positive slope coefficient, meaning the larger is the opening weekend gross, the larger is the world gross. Positive relationship. The estimated coefficient here means that for each 1 unit increase in opening weekend gross, and remember it's measured in millions, so for each additional $1 million in opening weekend gross, world gross will go up by 7.7 times that. We'll have, if I have an additional 1 million increase in opening weekend gross, my world gross would go up by $7.7 million. Another thing I look at is the overall F and the individual T. They give me the same information for a simple regression. When we look at a multiple regression, then we would get different meanings for the individual T and the overall F. In both cases, you see that the variable is highly significant. The T statistic is very, very large, and I would say that this variable is a good variable to include into our regression equation. I like to plot the residuals. I'm going to plot the residuals for all 4 of the regressions. I'll hold the control key down and meant to click on this red triangle. Control keys down, plot the residuals, and you get a lot of plots, but let's look at the first plot across there for each of the 4 graphs. And what I notice is, again, this doesn't look very linear on this equation, the theaters on opening weekend. And this variable, the spread, we have 0, the blue dotted line. And finally the 4th regression, again you see some variation about the line tends to be getting larger as the predicted y variable is getting large. We're looking at the shape of the residuals here. We'd like it to be fairly normally distributed to be able to make good inferences. Not too bad, but a little bit of a concern. Another plot that I look at is this normal quantile plot. More discussion in your book, but I'm looking for points, especially in the tail area, that might go beyond the dotted lines. The closer our points are to a straight line, that red line in the middle, and if they fall within our dotted lines around that straight line, then I think that the distribution of the residuals is fairly normal. So there you have it, an example of regression using JMP, and hope you enjoyed it. Bye-bye.